So hello everyone, my name is Bao. Today I'm gonna show you how to conduct a tensile test, which is very important for mechanical engineer. So basically the tensile test apply a tensile or tension load to the specimen to investigate the behavior of the material or how the material respond to the load being applied during the test. A tensile test can give you the view about how strong the material is and how much the material can elongate under the load. And basically the tensile test can be applied on some instrument like electromechanical, and like this one we are using today will be the universal tensile test machine. Its name is Instrong. I would like to explain a little bit how important the tensile test is. So in reality, when you design something, you need to find a suitable material. So like how strong the material is for your product, how brittle, how ductile. That's a very important requirement for a product design. So the tensile test basically provide you many things, many mechanical property. For example, the modulus of elasticity, the tensile strength, and the ductility, brittleness. All of them are very important. Okay, for plastic specimen, to identify the gauge length, you need to mark the two position. In this case, I already marked on the specimen, and the length will be 70 millimeter. And for cross-sectional area, you need to identify the width, the thickness, and the width of the specimen using the caliper right here. First of all, you need to measure the width in this position and then the other two positions along the gauge length, and similar to the thickness. And then you get the average value to make it more accurate. For metallic specimen like this one, we can measure the gauge length using the caliper between two solder here. And then for the cross-sectional area, you only need to measure the diameter. So in general, the gauge length can be identified based on the distance between two lower and upper grips. Doesn't matter what kind of geometry of the specimen. Before we start the test, there is some safety guidance you need to know. So everything must be clear from the testing area here. So including your hair, your hand, everything. Every tool must be removed from the testing area. And after you finish the loading, you need to pull down the safety seal. So that is very important. So don't forget this step before you start the test, to protect your eyes from the broken pieces from the sample. So first of all, we need to start with the plastic specimen first. For plastic specimen, we use this kind of grips. We call it wedge grips. Okay, it's very typical. So we start from the lower grip first. So because you already marked the gauge length here, so make sure that the contact point of the lower grip will be the same precision with the lower mark. Then you try to make sure that your specimen in vertical direction when you lower it into the grips, and then use the panel to move the upper crosshead up and down. So move very slow the upper head down very slowly until the contact point of the upper grip touch the other mark on the specimen. I will check it. And then clamp the specimen. So as I said before, now you have your gauge length between two grips here. Okay, for metallic specimen like we have today, will be the south end specimen with two solder at the end, as you can see. So for this kind of specimen, we need different grips. So we have here the split insert grips used for this kind of specimen. So first of all, I need to clamp it in the first insert right here. Okay, then put the rubber ring inside the top of the grips, and then the steering at the bottom. So we finished the first one. Okay, put it here on the bottom, then use the pin to locate the first half grips. For the second one, we do the same. Put two halves here, rubber ring, and then still. Okay, you need to hold the whole grips and specimen like this, and then use the panel, slowly move down the crosshead. Then another pin to locate the upper grips. Okay, one important thing you need to be careful before the test. You have to always check the tension of the specimen before the test. So we need it to be 0 at the very beginning. So as you can see here, the specimen still slack a little bit. So use your panel, move the crosshead up a little bit, very, very slow, until you find a little bit tension on the specimen. Now it's tighter. So now we can start from this position when you can feel a little bit tension. It's very important for this kind of specimen. And it's totally different from the practice one that I already introduced before. So we finished the loading of the specimen, including the metallic specimen and plastic specimen. So we need to put out the safety seal before we start the test. So next we come up with the software setup. The software we use for Instron Universal Test Machine will be Series 9. To start, click on Test to create a new file. Name your file aluminum. Choose what kind of test you want to use. In our case, with tensile, and the test for round bar depends on the geometry of your specimen. And then click OK. So the software will show you the initial graph between the load and displacement. These are two values you can get from the test. Click on default parameter to fill the dimension that you already measured at the beginning of the test. We have the diameter of the aluminum specimen will be 5 millimeter. The gauge length will be 27 millimeter. The crosshead speed I choose in this case for aluminum material will be 5. I follow the standard ASTM E8 for metallic tensile testing. The data rate will be 1 point per second. After finish all the setup, we click OK. And then now we can start the test. For plastic specimen, we need to use another method. First of all, click on Test again to create a new file. Name it plastic. Choose tensile. In this case, as I said, we choose this method, the general tensile SI unit for a rectangular cross-sectional area. Click OK. No, we don't need this. This is only for composites. Then click OK again. Click on default parameter. And the width for this specimen will be 10. And the thickness will be 4. The gauge length we have already measured before. It will be 70 millimeter. Okay. The crosshead speed for plastics I also choose 5 to make it consistent to aluminum specimen. The data rate again 1. Then we finish the setup for plastic specimen. Okay, so we finished the test for aluminum specimen. So next we come up with the steel specimen. So after we finish the sitting, balance the load and displacement, and then we start the test. Okay. Now we come up with the steel specimen. So So the profile of the load and displacement curve will be similar to the aluminum. But you can see that the load is much higher than why is it overflow? Okay, it's no. So the next specimen that we use would be the plastic one. As you can see that plastic one have the different geometry compared to the metallic specimen would be the flat one. That's why we need to choose another method. So first of all, we click on test again. Okay. To create a new name of the file, name is plastic. Click OK. As said, we need to choose another test method. Okay, in this case, for flat specimen like this one, we need to choose zero tensile test using SI units. And again, choose tensile method. Click OK to create the file. Ignore this function because we don't deal with the composite material. Okay, click again to confirm the test, the file. Click on default parameter again. So we have width and thickness. From the measurement, the width we have here will be 10, and the thickness will be 4 millimeter, and the gauge length will be 70 millimeter. I choose the crosshead speed for plastic specimen is 5 as well to make it consistent. So you basically for elastomer plastic like this, you can choose even higher speed. But in this case, I choose 5 for all specimen. And the data rate will be 1 as well. And click OK to start the setting. So now we're gonna deal with the last specimen, plastic one. So balance the load again and the displacement, and then start the test. Check the dimension. You see it's similar to the aluminum specimen. Also have like elastic region and then yield. Then the load start to decrease. Sorry. The only problem here is with plastic specimen, the displacement kind of much longer than metallic material, and the load is much lower. So after finishing all the sample, that's the result for steel, aluminum, and plastic specimen that we got today. First of all, I have to say that based on this graph, you can know many things related to the mechanical properties. For example, in this case, you can see how strong the material is. The first one will be steel, this line, and then the next line, the red line, will be aluminum, and the last one, the blue line, will be plastic. So the maximum load identifies the strength, the tensile strength of the material. In this case, you can see very clear that the steel is much stronger than aluminum, and then even much stronger than plastic. So similarly, for aluminum, you can see that the maximum load of aluminum is much higher than plastic. So basically, we can explain why plastic is very weak material based on this graph. And another material we can get from this graph will be the stiffness. We have different name for that: stiffness or Young modulus. Someone say modulus of elasticity. So in this case, I just say elasticity, modulus of elasticity. So will be the gradient of this elastic line for each material. So you can see that steel has the highest gradient of this line, means this material is stiffer than the others. Okay, and following by aluminum with this gradient right here, and the last one will be plastic, very low gradient right here. So the last property that you can get from this graph will be the ductility of the material, will be the ability of material can plastically deform until it's broken. So in this case, steel, we all know steel very brittle, right? So based on this graph, you can see the distance from the U point to the fracture point is very short. It's shortest compared to the other, like aluminum. Aluminum, this distance is a little bit longer. That means aluminum is more ductile than steel. And the last one, you can see the plastic specimen lasts like much higher, much longer than compared to the other two metallic specimen. That's why we all say that plastic is very flexible or ductile material. Okay, after finish the test, this is the result from the test. So I will show you for the sample, the aluminum sample. This test shows you everything about the testing condition for example, like the dimension you use, including the width, thickness, gauge length, for example, and the load, maximum extension. Every information will be displayed on this file. So the data we need to care will be these two columns. The first column identifies the displacement, and the second column identifies the load. Okay, so remember the unit. So the unit of displacement will be millimeter, and the load will be kilonewton. In this case, be careful with the unit. Okay. So I have to do something to convert from this file to Excel for your calculation, because you need to convert from the load displacement to stretch and strain curve using the formula that I told you at the beginning of the test. Okay, so I copy all of them. Remember, you don't use the minus value for the load. So this is based on the real test, but we not going to use this value. So remember, remove the minus value when you use the data. I copy all of them, then I create a new file. Okay, it's only column, and then I name it. Result, for example. Then you open your Excel. You will see the data function right here. Click on it. You have to use import external data. Okay, you already have the file you already say on desktop with the result name. Click on it, and then use delimited, and then next, comma, and tab. Click on tab and comma, and then click on finish. Choose the initial part, and then we have like single column for you ready to calculate for the stretch and strain. Okay, after finish all the tests, we will get the result, and the result will be displayed by this test file. Okay, so take a look on this file. You will see like every testing condition, including the data rate, the cross-test speed, the dimension that you already put in to the test, and the maximum load, maximum extension, everything. Okay, so we just care about these two columns. The second column identifies the displacement, while the last column will show you the magnitude of the load. Okay, you will need these values to convert from the displacement to strength and the load to stress, using the formula that I have told you at the beginning of the test. So one thing I need to show you is how to transfer the data from the test file to Excel file. So it's got a very useful technique. So first of all, I need to copy all of the value except the minus value. We don't need the minus value in our graph. Okay, so I copy it. Then I create a new file, save it anywhere. I save desktop, result file. I will say, so remember where you save it with the name of the file, and then click yes. Open your Excel. Then you will see the data here. Click on it and import external data, and then import data. So remember where you save your test file. I say on desktop with this name, result. I click open, and then you click on delimited. Click next, and then click on top, comma. You will see the format show here, preview. And then I finish. Choose the position when you want to start to import. Okay, click OK. Sorry, I choose another one. Okay, so you have like 3 separate columns. That will be very convenient for you to calculate, convert from the displacement to the strength and the load to stress. Again, be careful with the unit. Okay. So to make it clearer, I will name it for you, like displacement. And the load. You will need to and the unit will be you need to convert into strength. It's no unit for strength. Strength will be percent, and the stress will be megapascal. Right. So we finished all the tests for today, including the data collection and data discussion. As I already discussed something about the material property for you, and hopefully you will understand the importance of a tensile test. Can give you many properties. Okay. So if you have, if you want any extra information or any kind of books material that you find is necessary for your study, please refer to Dr. Zubran and for more information. Thank you so much. And